Okay, question number 5. This question will be published on 6th of December, Friday. Okay. A student pours a canned carbonated drink into a cylindrical container after shaking the can violently before opening. So you have a container and you have some carbonated drink into this and you keep on shaking it rigorously. A large volume of foam is produced that fills the container. A large volume of foam is being produced. Usually we do this with a beer bottle, nothing else. Okay, so now a large volume of foam has been produced. The graph shows a variation of foam of height with time. So this is the height, this is the time. Determine the time taken for the foam to drop to half its initial weight. Okay, so what is the time taken for it to drop it to initial height? What is the initial height here? Initial height, this is 35, 36, 37. So this value is going to be 37 centimeter, 37 centimeter. What is 37 by 2? 37 by 2 should be around 18.5 centimeter, right? 18.5 centimeter is 18.5 centimeter. This is 18.5 centimeter somewhere over here. Somewhere over here. So this will intersect this point at 19 over here. So therefore 19 seconds. So the answer for the first one is 19 seconds, right? Okay, if you get an answer between 17 to 19 seconds, it's always considered. Then what is the time taken by the foam to drop to quarter of its initial height? 1 quarter. So this is 18.5 divided by 2. 37 by 4 is nothing but 18.5 divided by 4. Again half of it, which will be equal to how much? Which will be, if I take 18, this should be 9 seconds. This will be 9 centimeter. Now let us take 9 centimeter. 9 centimeter should be somewhere over here. This should be a 9 centimeter. Corresponding to this, this should be 30, this is 32, 34, 36. So this should be 36 seconds. 36 seconds, and the answer is should be between 37 to 39 seconds. 36 seconds is 37, 38, 39. Yeah, 38 seconds. But we have got this 36 seconds. You can consider this. Then the change in foam height can be modeled using ideas of other areas of physics. Identify one other situation in physics. Where do we use this one in physics? If you remember, we use this in radioactivity, right? So you can write one other situation. I'll give you multiple situations. Radioactivity, we can use it. And if I have already learned something like electromagnetic induction, and if you are a student in your second year, then you will also learn this in modeling the capacitor's charge. The charge of a capacitor also drops in a similar way. Okay, and if you are a chemistry student, or maybe if you have done some IA based on Newton's law of cooling, you observe that the temperature of the hot water in an external environment also follows something like cooling law according to Newton, and this also follows the same rule. Okay, so therefore in all these situations you get a similar thing. Okay, so with this we come to an end to all the 5 problems for this week. Do subscribe to my channel for more such updates. I'll be bringing you more number of such interesting questions from various papers. And as you all know that we already started with the next part, that is your AS and A level questions also. So we will be doing first MCQs, and maybe some of them have already replied to me in my personal WhatsApp group saying that they need something like paper 3. Okay, so which they find it very difficult, but of course I have not explored so much, but we'll be doing it into shortly, and we will see in the next week about more questions. And next week we'll be working on questions related to SHM and circular motion. Okay, thank you once again.